Hello everyone. So welcome back to the live doubt lectures on engineering mathematics. So far we have done live doubt lectures and discussed questions on linear algebra. Like there were 3 sessions on it. And after that, the previous session was on calculus first class, which was on limits, continuity and differentiability. So in today's class, we are going to discuss, as the thumbnail says, we are going to discuss the topic mean value theorem, increasing decreasing function, local maxima minima or global maxima minima, what is the maximum minimum value, and then other than that we are also going to see Taylor's theories and Maclaurin series also, right? So apart from that, so good morning Kirti, good morning Lokesh, and Lokesh, there are like 2 Lokesh, huh? Good morning everybody. So today's session we are going to discuss mean value theorem and local maxima minima, increasing decreasing and all those. So meanwhile everybody is joining, I'll also request that you should share the link with your friends so that we can have more interaction and more energy in the class. And by the end of the session we'll know how to find the maximum minimum values and all that. So we'll try to discuss the gate questions and also make sure that we are also approaching the question in an analytical way so that we can save some time, because that is very important. Hi Kirti, could you please tell in English, sir, as I'm not. Of course, Kirti, I'm talking English, right? I'm not talking in Hindi also. And where are you from, by the way? Kirti. So, I'm talking English, not a problem, right? And the entire session will be in English only. If you want, you can see the previous sessions also. So, the point is, by the end of the session, we'll be covering we'll be knowing how to solve and approach the questions. More important is that we should know how to save some time also, right? Karnataka, good. Fine. So in that case, for all the people who are also new, should also check the app, should also check the Play Store and install the app and register themselves, and then you can also check the like whatever best courses you can have and the best promo code you can available apply to get the package also, right? So I think people are joining here, and we should start now. We are already like 11:03 now. So okay, and let's move to the questions now. I have installed and subscribed, sir. Very good. So we'll be discussing some 10 to 15 questions today. And good morning. Good morning. Right. So let's see. So this is the second live session on calculus. Make sure, and you have seen the first class also. Make sure that also, so that we have some of the properties being already used and discussed. You can see it here also being used and discussing, right? So let's start with the first question, which is from 2015, and it says, it is on mean value theorem. It says a function f of x, like given here, and is defined in the closed interval, and we have to see that in the open interval which of the value or which of the point is satisfying the mean value theorem, right? So before approaching this question, a small review of what is mean value theorem. It says that mean value theorem says for a function being continuous in the closed interval, differentiable in the open interval, right? You know this closed and open interval also, where a and b belong to some real value where a is less than b, then there exists a point zeta such that the f dash zeta is going to be f of b minus f of a divided by b minus a, right? So this is what we know, and in that case, applying the same theorem, we have to check that at some point we are going to get a point where this mean value theorem is going to be satisfied, right? So this is f dash, this is f of x. So let's write f dash of x here itself. This is going to be minus 2x plus 3x cube, sorry, 3x square, right? Now it says that we need f dash of zeta or c, anything, is going to be f of b minus f of a by b minus a. So what is b and a? B, the upper end will be 1, and a, the lower end, will be minus 1. So we can also find f of 1 and f of minus 1. What is the application of this theorem? This application, okay, the application of this theorem is to find the nature, the concavity of the nature, and in that case it will going to help you find other further things which is of use, right? So let's see. So b and a are 1 and minus 1. In that case, let's put 1 in this case. F of 1 is going to be 1 minus 1 and plus 1, so this is going to be 1, and f of minus 1 is going to be 1 minus 1 and minus 1, which is minus 1. So in that case, let's put it in the terms of x only. We are going to get minus 2x plus 3x square is equal to f of b. So it is going to be, I'm writing it here, 1 minus of 1 divided by b. What is b? B is 1 minus a. A is minus 1. So this is overall going to be 1. So I'm writing it like this. So now, in that case, what we are getting is a second order equation, which is 3x square minus 2x minus 1 equal to 0. So we want that this equation should be satisfied. So we can find the roots of this value, this equation. The roots, if you see, this can be written as, this minus 2x can be written as, let's say, minus 3 and minus x. So let's take 3x common. This will be x minus 1, and let's take minus 1 common. Yes, or you can take simply minus 2x. 1 second. This is 1, this is minus 1. So the roots, what are the roots coming here? This is plus 1, right? So in that case, you can take plus 1 equal to 0. So the roots are going to be x is equal to minus 1 by 3 and x is equal to 1. So we know that this point should lie between the interval. So the interval was minus 1 to 1, and the point which will lie between this interval is going to be this point, x equal to minus 1 by 3. So this minus 1 by 3 is the point where this will be satisfied, and this is going to be the answer, right? This is what we are looking for. So this is the answer. Let's see the next question then. Yes. Let's see this question. This says, according to the mean value theorem, we have to find that the function in this interval, there exists a zeta such that this is going to be what, right? So we have to find this value. Now before solving this equation, let's see, there's a basic property of calculus which says, let's say, just let's say that capital F of x is a function which can be written as 0 to, let's say, x f of t dt, right? In that case, we have to make sure that this function f of t dt should be continuous in that interval, whichever interval we are discussing. Then we can also say f dash of x is going to be simply f of x, right? This is a fundamental property coming from calculus. Now what we can do is, instead of writing this, so this was just for an understanding, what I'm trying to say is, if for this interval a b, if f of x is continuous and differentiable, because we have to apply mean value theorem, so it has to be continuous and differentiable in this range, then we can say that f of x, let's say we are assuming this was a function just for an understanding. So let's say we have a function f of x which is given as from a to x, I'm writing it as f of t dt, f being the same function but the variable we are changing as t, and instead of x we are writing d, right? So why we are writing from a to x? Because the function is defined and continuous in the interval of a to b. We cannot mention it to be x, right? And we have to make sure also that this x lies between this a to b interval only, right? So in that case, what we can say is, the second thing is, if the derivative for capital F of x can be written as f of x, right? Also, any other point we'll see what we can apply. So mean value theorem for capital F of x, instead of small f of x, we are applying it for capital F of x, and we are saying f of some point zeta, f dash of zeta is going to be f of b minus f of a divided by b minus a. We can write this. Of course, there was a reminder on YouTube, right? So there won't be a problem with that. So f dash of zeta is going to be f of b minus f of a by b minus a. In that case, what we can write is, let's say what this a is going to be, capital F. It is going to be, I'll have to move up. It is going to be from a to a f of t dt, and this has to be 0, right? This has to be 0 because you can apply it here. What if this x is equal to a? Then it is going to be 0. So that means this value is going to be 0. Let's say what is f of b, we keep it here like that only, and this is f b minus a. Now f dash of x can be written as small f of x. So this f dash at zeta can be written as f of zeta, and f of b, if you apply x is equal to b here, this is going to be integration from a to b f of t dt by b minus a. So in that case, what you will get is f of zeta into b minus a is equal to integration from a to b f of t, instead of t we can put x also, x dx. So I think this is what they are looking for. Yes, from a to b. So the answer is going to be f of zeta b minus a, option A, right? So this is the answer we are going to get, right? So we are using some of the basic properties of the fundamental properties of calculus, and you can like check this as mean value theorem for integration or differentiation like that, right? So A is going to be the answer. Now we are moving to very interesting topic, which is increasing, decreasing, maxima, minima, and like that other functions. So let's see. In this case, it says the derivative of the symmetric function is going to be what? So please try this question. It is not a difficult one. But to start this, I'll say we know this, that if a function is increasing, right, it means when the x is moving to the right side from left side on the x-axis, if the x is moving from left to right, the function value should increase. Then you say the function is increasing, and if it is decreasing, then you say it is decreasing. And mathematically, the derivative of this function has to be greater than 0 if it is increasing, and it has to be less than 0 if it is decreasing, right? This is what we already know for an increasing or decreasing function, and if the derivative is 0, it is going to be a constant function, right? So moving x from left to right, right, from the lower value minus infinity towards infinity. So if you check this function, C option, C is the right option, Lokesh. So this option says, if you see, for this left half 0 minus and right half 0 positive, if you see the function is increasing in this case and it is decreasing in this case. So the derivative of that function has to be for increasing greater than 0, and derivative has to be less than 0 for decreasing function. So that is for x less than 0 and x greater than 0. So in that case, you can see that this is the option where the function derivative not function. Function derivative is positive and function derivative is negative in this part. So that means all other options are wrong, because let's see for the first example, first option, the derivative value is above y equal to 0, or you can say x-axis, right? So this is always positive. This is also positive, this is also positive, this is negative, and this is positive. So the right answer is going to be C, right? Correctly said, Lokesh. So C is going to be the right answer. Let's move to the next question then. I'm sure this is clear. Let's try the next question. So it says there is a function f of x is equal to x cube minus 3x square plus 1 in the range of -1 to 3, and you have to find whether it is monotonically increasing and decreasing, like that. Like we have to check the nature of this function. So what we can do is we can check the nature of the derivative, and that will tell us whether the function is going to be increasing or decreasing, or monotonically increasing, or not changing with the decreasing nature, right? So for f of x is equal to x cube minus 3x square plus 1, the derivative is 3x square minus 6x, right? And in order to find this nature, what we can say is, we can either apply the stationary point. Conventionally we can apply the stationary point and check, like the stationary point can be given as f dash of x is equal to 0. So this 3x square minus 6x is equal to 0 has the roots. You can clearly see, if you are taking 3x common, it will be x minus 2 equal to 0. So the roots are going to be x equal to 0 and x is equal to 2. So these are two roots of the function. And if you check the nature of this function at x equal to 0 and x equal to 2, that will also help you to find whether the function is going to be increasing or decreasing. But let's not do so anything, right? Let's find a different method. If this is the derivative of this function, f dash of x, can you see this is a second order polynomial equation? And if it is a second order polynomial equation, it is going to be a like parabolic graph. So let's say this is our x-axis, xy plane. Now we can also, we have already seen the roots are x equal to 0 and 2, and the coefficient of x square is positive. That means the graph is going to be upward, and the roots are 0 and 2. So let's say this is 0 and let's say this is 2. So the graph is going to be of something like this. So that means for this is x equal to 0. So for 0 minus, and for this range of 0 to 2, and for let's say 2 plus, all this range and all this range. So you can see that for this part, this value is like above the x-axis, so it is going to be positive. This is negative, and for 2 plus it is going to be positive again. So if it is positive, it is increasing the function. This is the derivative, which is positive, negative. This is the function, which is if the derivative is positive, it is increasing. If the derivative is negative, it is decreasing. And if the derivative is positive again, it is going to be increasing. So somewhere, I'm roughly saying, the graph is going to be increasing and then decreasing and then maybe again increase, right? Let's say this is these are going to be the point x equal to 2, x equal to 0. You can remove this one. So this is going to be 0, this is going to be 2. So you can clearly see the function was increasing first, then it is decreasing, and then increasing again. So in that case, increasing, decreasing, and increasing again. Option B, right? So this is what we did graphically. If we were not doing it graphically, what we would have done? We could have gone for second derivative. Like mathematically, conventionally, if you're doing it, you can go for second derivative, and if this is the first derivative, the second derivative is going to be 6x minus 6. So let's check f double dash at 0 and f double dash at 2. At 0 it is going to be minus 6, and at this point it is going to be 6, I guess. So what we have to see is this value is negative and this value is positive. So if the double derivative is negative, that point, which point? That point x is equal to 0 is, let me write above. So where the double derivative is negative, that point is going to be maxima, and the double derivative being positive, that point x is equal to 2 is going to be minimum. So that will also help you to understand that maxima is something like this and minima is something like this. So this is going to be x equal to 0 and this is going to be x equal to 2. Something, not exactly like this. So that also says the same thing. We are getting the same nature of the graph. We are talking about the nature of the graph, not exact points and values, right? So that says again that you will get the answer that it was increasing, then decreasing, and then increasing again. So it is up to you. You can choose whether you have to like analytically just check the graph, whether like if it is parabolic. Many other case like polynomial equation, it is very easy. If you see the third order equation, the second order is going to be polynomial. You can find at what range the function derivative is going to be positive and negative graphically also, right? So this will be done like this manner. We have approached in both the manners like here, right? So let's see the third question on this. While minimizing the function f of x, necessary and sufficient condition for the point x naught to be a minima. So we already saw that we need a stationary point. First of all, stationary point is must to have an extrema, right? Then if that is what, that is f dash of x equal to 0, and then we'll check the double derivative. If the double derivative is positive at some point a, then it is going to be minima, and if it is less than 0, then it is going to be, let's say b, then it is going to be maximum. So very obvious, we have to find that the derivative should be 0 and the double derivative should be greater than 0, T option, right? This was a theoretical question, but I have kept it just to so that we can easily move to the next question also, right? So that's it, D option. For minima, it has to be like the double derivative has to be greater than 0. This one I'll suggest that you can of course do this by your own. Why? It says you have to find the nature of increasing and decreasing. Again, we have to do what? Option D is the right answer, Lokesh. So in this case, what we can do is can simply check that f dash of x. I'm directly writing it because you can find the derivative. I'm not spending too much time. It is going to be e to the power of x by 1 plus e to the power of x ka square. And in that case, this value e to the power x is also positive. The square of this value is also going to be positive. So positive by positive is going to be positive. So this derivative is always greater than 0, which means it has to be always increasing, right? It has to be increasing function. That's it. So you can do it by yourself. Anyways, we have like almost done this question, so not a problem, right? Let's see this interesting question. Again, I'm telling you that we can apply both the methods. You can do it conventionally or anything. So it says that this is the function given, and we have to see that which is the possible graph of this function, right? We have to find the possible graph of this function. So this function f is e to the power minus x into x square plus x plus 1. The derivative I'm writing is e to the power of minus x and minus of the derivative. You can directly find the derivative. I'm still doing it for you, but you can do it by yourself also. Minus x square plus x plus 1 for the derivative of e to the power minus x, and the derivative of the polynomial part is 2x plus 1. So it is minus x square minus x and plus x will become plus 2x will become plus x, and then that's it. So the stationary point is like this, e to the power minus x is not going to be 0. It is going to be 0 at maybe at infinity, right? So let's not discuss about it. Let's discuss about this point where this function is going to be 0. So this is going to be 0 at x equal to 0 and 1. How? Find the roots. Find the roots of minus x square plus x, right? So you'll get the roots being x equal to 0 and x equal to 1. So that means these are the point which will be acting as extrema. It can be maxima or minima, any of it. We haven't found it. We have just found that this is a stationary point, right? We have found that this is a stationary point. We haven't seen whether it is maxima or minima. So let's it's okay. What my concern is, let's talk about the nature of this derivative again. So this derivative f dash of x, which is e to the power of minus x into minus x square plus x, right? Good morning, Guru. So let's see. Let's talk about the point. This, let's say this is 0, this is 1, right? If you see again, this is a, like graphically, if you're trying to solve this derivative, this is always going to be non-negative value. So let's talk about minus x square plus x. If you see the roots, we have already discussed to be 0 and 1. The roots are 0 and 1. The negative coefficient of minus x square tells you that the graph is going to be downward. Good morning, Aditi. So this graph is going to be downwards, and this downward graph is going to be something like this, right? A downward parabolic graph, because it is a second order equation, right? And the roots are known as x equal to 0 and 1. So now you can see for values less than 0, it is negative. For value greater than 1 also it is negative, and for value x between 0 to 1 it is positive. So what I am trying to do is, I am trying to like avoid some of the calculations required. Instead of that, just analytically check the graph. So the graph tells you that this was for f dash of x. Now f dash of x is not minus x square plus x. It is e to the power minus x into this function. But this e to the power minus x is never going to be negative. So the negative and positive nature of the derivative will be decided by this function minus x square plus x. Clear? And that is why I am dealing with this part. So this says that the function which is f of x is going to be increasing, sorry, the first half is decreasing, then increasing, and then decreasing again, right? The part where the derivative is negative, it is going to be decreasing, then increasing, then decreasing again. But now you can see the graph, like the options for f of x has nothing on the left half of the x equal to 0, right? All the graphs are on the right half of the x equal to 0. But still, you can see that as soon as the graph starts at x equal to 0, it has to be increasing. So you check the options. A option is like it is decreasing nature, and also decreasing nature. So all three options are going to be wrong, because B is the option where the graph is increasing first and then decreasing. Okay, so that is what we expect. And if it would have been on the left half also, it was supposed to be decreasing. So decreasing, increasing, and then decreasing again. So that means by the nature of the positivity and negativity of the first order derivative of the function, it tells you the nature that the function is going to be increasing and decreasing, and that finally tells you that B is going to be the answer, right? B is going to be the answer. I'll give you one more analytic understanding here. If we have found x equal to 0 and x equal to 1 as the stationary points, because this is the place where f dash of x equal to 0, then the number of extrema for this equation is going to be 2. The number of extrema is going to be 2, and that is where it can be maxima or minima, any of it. If you see that C graph, this is a point minima, this is a point maxima. That means apart from x equal to 0, of course this is not x equal to 0, this is x not equal to 0. We have x equal to 0, so x equal to 0 means this point, right? So that means apart from x equal to 0, we have one extrema here and one extrema here. So that makes it 2 or maybe like 3 extrema if we are counting x equal to 0 here. But we don't have 3 extrema, we have only 2 extrema. So this option has to be dropped. Similarly, this is one extrema, this is one extrema, and these two are non-zero extrema. So if these two are non-zero extrema, the 0 extrema makes it 3 extrema again. So again D option has to be dropped, and A option we have dropped because the nature is exactly opposite of what we are expecting. We are expecting it to be increasing after x equal to 0. So you can check it anyhow. You can manage to check your positive, because you have to check the nature. You don't have to check the exact values, right? So this is how you can find the values. So B option was the right answer. Let's try the next question. It says, it is a very simple question. Of course, you can do it. It says that the point x equal to 0 for the function f of x equal to x cube. So if f is x cube, f dash is going to be 3x square, and at x equal to 0, this f dash is going to be 0. If f dash is 0, you can say that it is going to be a stationary point. We are expecting extrema or extrema like maxima minima. But the second derivative of this function is going to be 6x, and at x equal to 0, again the double derivative is also 0. So the first derivative is also 0, the second derivative is also 0. So what about third derivative? Third derivative is 6, which is not equal to 0. In fact, it is a constant value. So it says when D option is the right option, Lokesh. So it says when the concavity, when you have found the stationary point, after that when you look for the second derivative, if it is changing from positive or negative, or whether it is positive or negative, that only tells you whether it is going to be local maxima or minima. But if you talk about x cube, this is the graph we have for x cube. So if you see this x cube graph, of course the first derivative is 0, because you can see the slope at this point is going to be parallel to the x-axis. So the derivative is going to be 0. And second derivative is also going to be 0, and that tells you that the concavity of the graph is going to change, right? This is concave down, right? If this is concave down, this is concave up. So this concave down slowly changes its nature to concave up, and that point where the concavity of the graph changes is the point which we say as point of inflection. So in that point you may not get maxima or minima. You can clearly say this graph of x cube, it is neither maxima neither minima, even at the local level, right? So this is the point which is we are discussing at x equal to 0 here, and you can say that this point is going to be neither a local maxima or local minima, correct? So let's move to the next question. Let's see this. D was the correct option, Lokesh. Let's move to the next question. It says which of the following is not a correct statement. So the first option is, option A is, let's say y equal to x root of x. We can write it as x to the power of 1 by x. We can also write it as e to the power of ln of x to the power of 1 by x, and of course we can also write it as e to the power of 1 by x ln of x. I have just used the properties of log and anti-log and all, right? So we can write this function as like this. Now the derivative of this function can be easily found. E to the power of 1 by x into ln x will be e to the power of 1 by x into ln x into 1 by x derivative will be minus 1 by x square into ln x plus 1 by x into derivative of ln x, which is 1 by x. So I'm writing it as y dash is equal to e to the power of 1 by x ln x is directly y into 1 minus ln x divided by x square. What is y? Y is x to the power of 1 by x, right? Or this value, anything. Now you can clearly see that this value is going to be non-negative, right? It cannot be negative. It has to be positive. It has to be positive always. So if you see this y dash, this value is always positive. This x square is also always positive. What we are left with is 1 minus ln x. This 1 minus ln x is what will decide the positivity or negativity of the derivative of the graph, not the function, derivative of the graph. So let's talk about 1 minus ln x. Let's say what is the stationary point. So ln e is going to be 1. So x is equal to e is the stationary point, right? And now we also know that ln x is an increasing function. If not, let's talk about e minus point and let's talk about e plus point, right? The value is greater than x and the value greater than e, like that. So 1 minus ln x for x less than e is going to be less than 1. So 1 minus something less than 1 is going to be positive value, and 1 minus something value which is greater than 1, I'll say this is less than 1, so it is going to be negative value. That means the function, this was about the derivative, but talking about the function for values less than or greater than e, you can see the function for derivative being positive is increasing, and for function derivative being negative it is going to be decreasing. So the graph is going to be something like this, and this is the point x is equal to e. So if this graph is going to be something like this, that is concave down, that this point is going to be a maxima, it is not going to be a minima, right? That means it cannot be a minima. Option B is wrong, because either it can be a maxima or it can be a minima, or if it is not a extrema. What is that the case? We have already discussed in the previous question. It was when the first derivative is not changing, right? It was possible, like in the previous case of x cube, if at x equal to 0, less than that also it is positive. Which one? The derivative. And greater than that also is positive. Then we can say value less than x equal to 0, it is also still positive, the derivative, and for x equal to greater than 0 also the derivative is positive. Then we will say that this point is not going to be a local maxima or minima, any of it. If otherwise, if it is negative and negative both, what I am trying to say is the derivative nature is either positive on both the sides or negative on both the sides. Then you cannot say it is going to be a maxima or minima, right? It has to be changing the nature. So in this case, instead of finding the double derivative, because finding the y derivative was only like too much, finding the double derivative is going to be again too much. Like we have to differentiate this and check the nature of the values, whether it is positive or negative. So that will be too much. Instead of that, if we can check the derivative values, first derivative values nature as being positive or negative, then we can see that the graph is going to be like this, and this will tell you that the function is going to be maxima at x equal to e. So if it is going to be x equal to e maxima, B option is the option which will be wrong. So you may not check C and D option now, but if you still want to check C and D options, then also it is not a problem. What we can do is, so what we did is conventionally finding the stationary point, then we should have gone for second derivative and checked whether it is going to be positive or negative at that point. But finding second derivative is like difficult here. I mean, it's not like it cannot be done, but it is too much for a 2 marks question. So instead of that, what we are trying to do is we are checking the nature of the first derivative changing from positive to negative, right? Now C option is x cube. C option we have already discussed that it will not have maxima or minima. We have already seen in the previous question. D option says it has a global minima at x equal to 0. You must be knowing what is the difference between local minima maxima and global maxima minima. X cube mod x has a graph of this, and it is going to be a minimum value at x equal to 0. This, it is x equal to 0 will give you f equal to 0. So this is the minimum value, overall minimum. So if it is overall minimum, you can say it to be a global minimum value, right? So x equal to 0 is a global minima, whereas this is the global minimum value of that function, right? Mod x. So that means C and D are true, only B option was wrong. So let's finish it here and let's move to the next question. Let's see this one. It is a simple question. Can you tell me the answer? Let's see. The first equation is x dash x1 dash and second equation is x2 dash, right? And it says initially x1 at 0 is less than x2 at 0. So if you are starting from t equal to 0, what we'll see is x2 minus x1 should be positive because x2 is greater than x1 and x1 minus x2 is going to be negative. So what is this x1 dash? It is the first derivative of this function and x2 dash is the first derivative of x2 function. So if this is positive, it is increasing, and if it is negative, it is decreasing. So, and of course x2 value is higher. So let's say this is x2 and this is x1. Function value of x2 and function value of x1 at 0, right? And x1 dash is increasing, so x1 will be moving up, and x2 dash is negative, so it will be moving down, right? But this derivative is a function of x1 and x2. So at one point what will happen, these two values going to be same. At some point this x1 and x2 are going to be same. This was x2 and this was x1. So at some point when it is same, this value is going to be 0 and this is also going to be 0. And as soon as the first derivative and second derivative are 0, it means that it is going to be a constant function, right? F dash is equal to 0 means constant function, which means from now onwards we have seen a dotted line, but after that what will happen? From now onward it will be a constant value moving together, and of course both x1 and x2 are same. So the graph is going to be like this. It is not extending to like upward and downward. And after that we can also see, so that means A option won't be there, B option won't be there, any of C or D is going to be there. Now why it has to be less than infinity and why not equal to infinity? Because it has been said that these values are finite. x1 and x2 values at t equal to 0 are finite. So, and that too x2 is like higher value which is decreasing. So a value which is finite is decreasing will be still finite value, and a value which is less than finite, that x2 is increasing and reaching here. So this is also going to be finite value. So that means this x1 and x2 is going to be less than infinity. It cannot be infinity because initially it has been given it has to be less than infinity. So a value which is finite decreasing will be less than that, no? So that means D is the answer. C is not the answer. D, sorry, correct. No. C is the answer. D is not the answer because it is not going to be infinity. It has to be less than infinity. So C is the answer. Equal to in the sense less than that, right? This is done. Let's move to the next question then. A third order equation and we have to see the maximum value of this function at in the interval of 0 to 2. So when you have to find the maximum or minimum value, the points where we have to check is the critical point, that is stationary point, the end point, and the point where it is singular. So singularity, I'll say. A polynomial function is differentiable and continuous for all the range, so it won't have any singularity. So we are left with endpoints and the stationary points. So to find the stationary point, we'll have to find the derivative, which is how much? 9x square minus 14x plus 5 equal to 0. Can you see if you put 1 it will be 0, 9 minus 14 plus 5, that means 9 is going to be 1 is going to be a root of it. Anyways, you can also see that 9 into 5 and 9 plus 5 is 14. So write it minus 9 and minus 5. So 9x x minus 1 and minus 5 equal to 0. So the roots are x equal to 1 and x is equal to 5 by 9. So all you have to do is find the value of f of 0, f of 5 by 9, f of 1 and f of 2. So you have to find the values at stationary points, which are 5 by 9 and 1, and the end points which are 0 and 2, like the intervals are given, right, 0 to 2. So find the function value at these points and check for the maximum value. Out of this, the maximum value will be the answer. The answer is going to be, I think, 12 or something. I think it will be for the case of x is equal to 2 and the answer will be 12. Please check it. F of 0 is going to be very easy. It is going to be directly 6. F of 5 by 9 is going to be a bit calculation will be required. I'm writing it as 3 into 5 by 9 cube minus 7 into 5 by 9 square plus 5 into 5 by 9 plus 6, and f of 1 is going to be simply 3 minus 7 plus 5 plus 6. F of 2 is also going to be 3 into 2 cube, which is 8, minus 7 into 2 square, so this is 4, and plus 5 into 2 plus 6. This value is going to be 7. This will be a lesser value. I'm telling it. I'm not calculating, but I'm telling it is going to be a lesser value. You can calculate it. And this last f of 2 is going to be 24 minus 28 minus 4 plus 6 is going to be plus 2, and this is going to be 12. So 12 is going to be the answer. So f of 2 will be the value which will be maximum. You have to always check what are they asking, whether they are asking the maximum value or whether they are asking the point where the maximum value is occurring, right? Where the value is maximum or what is the maximum value. So they are asking the maximum value of f of x. So the maximum value of f of x is 12. But if they were asking what is the position at it will get, then you could have said x is equal to 2. So please take care of the difference and like what they are actually asking. So x is equal to 12 is the answer. Sorry, function f of x is equal to 12 is the answer. Next one. Minimum value of the function occurs at, so they are not asking the function value, they are asking the position occurs at what point. I won't solve it, right? I won't solve it, but I'll tell you what are the possibilities occurring here. Let's see. First of all, f of x is given like this. So what is the f dash of x? F dash of x is going to be x cube, so 3x square, it is going to be x square, and minus 3x divided by x, so that will be minus 1. So the roots are plus and minus 1. Let's say minus 1, let's say plus 1. These are the roots, or you can say the stationary point, right? If you equate it to 0, you'll get this, right? These are the stationary points. So what you can do more, you can check if possible, if this is x square minus 1, what will be the graph of this function? It is going to be like this. This is minus 1 and this is plus 1, right? So that means for this minus 1 and for this plus 1, within this interval this function is negative. What is negative? The first derivative, not the function. The derivative is negative, and beyond this it is positive. It is positive. That means f of x, if you see, if this is minus 1 and this is 1. For the derivative being positive, it is increasing. For the derivative being negative in this range, it is decreasing and again increasing, right? So can you see that this function in that case should be like this? I'm just talking about the nature, like that. This will be x equal to 0. You can find it, but that is not required. What I am concerned is the nature of this graph f of x. By looking into the nature of derivative, like negative and positive nature of derivative, we can see the increasing decreasing nature of the function. And if we know this, we can see that this function is increasing for less than minus 1 and increasing for greater than 1, and between this it is decreasing. So you can clearly see that this function will be obviously having the minimum value at minus 100. Minimum value, this is the possibility. It cannot have any like, because minus 100 is very far, right? It is very far and it is an increasing function. So as soon you are coming from minus 100 towards minus 1 or 0 or 1, the function will be increasing slowly up to 1, up to minus 1. That means without calculation also you can say that at minus 100 the function is going to have a minimum value and the maximum value is going to be at x equal to 100. This is possible only if the interval is very big. This interval from minus 100 to 100 was very big to tell it like just looking into the graph. Shahil, how did you know it's negative between the points and positive outside of them? I am talking about f dash of x. F dash of x is this. Please check this. Sahil, check this. This is the first derivative x square minus 1. So the parabolic graph, x square minus 1 is a quadratic equation which is second order equation. So the coefficient of x square is what? It is positive. So the positive nature of x square tells you that the graph is going to be upward. It is not going to be downward. Parabolic graph is for the second order polynomial equation. So upward graph is coming because the coefficient of x square is positive. Now you have to check the roots and check the nature. So this is a basics coming from functions from 11th 12th class, right? A basics from 11th 12th of the functions graph, where you can see that x square minus 1 will have a graph of this nature. So if it is having a nature of this, you can clearly see that within this interval it is going to be negative, positive outside, positive outside. Are you getting my point? If you just, as a homework, you try to draw the graph of x square minus 1 and all the polynomial equations, second order equations, we got it in today's class. In today's class, we came across like 3-4 polynomial equations of second order as a derivative or direct function. So you try to draw the graph of those functions. That will help you to avoid calculating the values. That will help you to find avoid calculations and just checking the nature. So why I am applying this concept here? Because this interval is very high. You cannot apply it for the range of, let's say, if it would have been minus 2 to, let's say, 3, it would have been difficult for you to do this. In that case, you should find the values directly. But being the interval being very high, you can see from a very long period, from minus 100 to minus 1, this function is increasing. So very long period this function is increasing. That means minus 100 is going to be a minimum value. And after that, for this minus 1 to 1, there is a certain change of like increasing and decreasing nature. But after 1, from 1 to 100 and maybe to infinity also, this function is increasing again. So if you have to find the increasing value, you can clearly say that at 100 it is going to be increasing, because that is the ultimate nature of this graph, that cubic graph, right? So why I am explaining this much and why I am spending so much time here? Because you can avoid calculating. Getting my point? Otherwise, it is very conventionally what you could have done. You could have gone for first derivative, then second derivative. Second derivative would have given you the values, or if they want the minimum values, you can have found. Otherwise, what you could have done, you could have checked the values at minus 1, f of 1, f of 100, and f of minus 100. You find the values at these 4 points and you can clearly see that which is going to be minimum and which is going to be maximum, because it is a polynomial equation, so it won't have singularity. So we have to check it where? We have to check it at singular points, we have to check it at end points, and we have to check it at stationary points. So polynomial equation won't have singularity, check it at end points and check it at stationary points. So we have to check at 4 points. But if you know the nature without looking into this, you can say that minus 100 is going to have the smallest possible value and 100 is going to have the highest possible value. Let's move to the next question. The optimum value of this function. Optimum means it can be maximum, it can be minimum. Okay, sir, understood. Thank you, Sahil. Thank you. Right. And for the practice part, I have told you what to do at home after the class is over. Right. So let's talk about this function f of x equal to x square minus 4x plus 2. So let's do it conventionally, right? Yeah, like because you need this basics of graph also to understand the way I am explaining it. So this function, we need to find the optimum value. So what we can do is we can find the derivative, which is 2x minus 4. We can find a stationary point, which is f dash of x equal to 0. So 2x minus 4 equal to 0 will give you x is equal to 2. And the endpoints are how much? Endpoints are not given. Endpoints are not given, but there is only one extrema here. So what is the double derivative? From here you can see the double derivative is how much? 2. So if the double derivative is 2, which is greater than 0, that means x is equal to 2 is extrema and it is a minima. So if it is a minima, the graph is going to be like this, right? And that means at x is equal to 2, it is going to have a minimum value. What are they asking? They are asking the function value. So x is equal to 2 is a minima, fine, but they are not asking minima, they are asking the minimum value. So minimum value is going to be f of 2, which is 2 square minus 4 into 2 plus 2. So there's 6 and minus 2. So minus 2 is a optimum value, but what is this optimum value? It is optimum, smallest optimum. So you can say minus 2 is the minimum value. So you can see option D is the answer, right? So this was I'll say done conventionally, finding the stationary points. We don't have end points, but we have to see that there is only one extrema. If there is only one extrema, it could be either like this or like this. That means that extrema is only going to give you the maxima or minimum value overall, right? If there is only one minima, then this point is going to be the minimum value. If there is only one maxima, then this point is only going to give you the maximum value of the function. Correct? Fine, done. Otherwise I could have like try solving this equation also as graph. You'll see that the roots are going to be 2 plus minus root 2, and that 2 plus minus root 2 will have that middle point as x equal to 2. Can you show the types of curves which different types of questions make? Please revise. See, for polynomial equations I can of course tell you directly 2 minima. Of course 2 is a minima. 2 is a minima, but they don't want you to minima and maxima. They want the value, function value. Minima, maxima is the location. Always take care of this. Minima, and maxima is the location. That is x equal to 2, x equal to 3. So that is the position of x. But the function value at that point is going to be the minimum value of the function or maximum value of the function. So there's a difference between minima, maxima and minimum, maxima. So that's what I'm telling. No, x is equal to 2 is a minima, of course, but the function value f of 2 is minus 2, which is the minimum value of what? Of f of x. Minus 2 Kirti, what is it? It is minus 2 minimum value, not 2 minimum. Yes, I'm saying minus 2 is the function value at x is equal to 2. Please take care of this. Minima, minima and maxima is the location of x. Whereas f of x at that point is the minimum or maximum value of f of x. That is the difference. Getting my point? There is a difference. You are not, they are asking you optimum value of the function. Whereas in the previous question, the minimum value of this function occurs at what point? Occurs at what point? So please try to understand. In case I think many of you are having this confusion. Let me tell you. Let me explain. Let me give you a basics. Everyone, Aditi, Kirti, everyone, Lokesh, Sahil. Let's see this. What I am telling you is, let's say we have a graph this. Let's assume this is a graph, right? We don't have anything beyond or after that. Then this is a point, roughly I'm saying, this is a point where this function value is attaining a minimum value. Okay? This is f of x, and let's say this point is x is equal to a, this point is x is equal to b. Please check the recorded classes, that will help you, right? So at x equal to a and x equal to b are minima, x equal to b is a maxima, right? But the value, let's say this value at this, let's say this is y-axis and let's say this is x-axis, fine. Just make it straight. So this value f of a is a local minimum. Local minimum what? Value of the function f of x. Whereas let's say this is f of b. So f of b is what? This is local maximum value of f of x. So try to understand that maximum minimum value is for the function. Minima, maxima are the position of that point. So this x equal to a is a position. X is equal to b is a position. Whereas this f of a and f of b are the function values. You're getting my point? F of a and b are the function values. So in this question we were discussing in our question, in this case, you check what are they asking? They are asking the optimum value of the function. They are not asking the position where it is occurring. No, they are asking what is the value. So it is occurring at x equal to 2. This is merely a position. X is equal to 2 is a position of minima, whereas the value is f of 2, which is minus 2, which is the minimum value of the function. Clear? Fine. Okay, let's move to the next part. So this is, now you can go through what I have said it again and again and explained separately also. You'll get it, definitely you'll get it. There's a difference. So let's move to the next topic, which is Taylor series and Maclaurin series. Right. Before starting this, let's see what are the basic formulas. The Taylor series, like I'm writing one more. Yes, Kirti, thanks. Okay, Aditi got it. Thanks, Lokesh, everybody. So, f of a plus h can be written as f of a plus h, f dash of a plus h square by 2 factorial, f double dash of a, h cube by 3 factorial, f triple dash of a, and so on. This is the Taylor series. Now if you put, in short, I am just telling you, in short, if you put h is equal to x minus a, what you'll get? This function becomes f of a plus x minus a, which is finally f of x. And instead of h, now you can write x minus a. So you see this, this is what you'll get. F of x becomes f of a plus h. So instead of h, they are writing x minus a into f dash of a, h square. So this is x minus a square f double dash by 2 factorial and so on. So this is the expression for Taylor series, and when x becomes 0, so this is the Taylor series expansion about the point x equal to 0. In that case, what will become? Like this is the a equal to 0 case. So a equal to 0 case, what you will get? That this function becomes like this, right? So this is Maclaurin series. So of course you know the formulas. I have just given it for the reference. I'm not going to discuss that concept part. We'll be moving to the questions, right? This is the small understanding of the subject. So when they say they want the expansion about some point A, that some point, let's say A, so that is this A they are talking about, right? Fine. So let's move back to the equations. So the first question is direct question. It says for a small value of h, the Taylor series expansion of f of x plus h is what? So it is a very direct question. We have already seen the formula also. It is going to be f of x, just for your reference, right? So this is A option is the right answer, and it is a direct question. I'm not solving it. It is a direct question. So you have to just tick the answer. Now we'll go to the second question. Second question says that there is a function f of x. This is f of x. What is f of x? F of x is e to the power x plus sine x. And they want it is about the point x equal to pi. So this pi is nothing but a. And then as I told you, h will be x minus a. So that is x minus pi. Getting it? They are telling the expansion is about the point x is equal to pi. So that pi is nothing but a. And pi is equal to a gives you h, like we have already seen, h is equal to x minus a. So x minus pi. So this f of x expansion will be f of a plus x minus, like instead of h, I am writing x minus pi, f dash of a plus x minus pi square by 2 factorial f double dash of a, and so on, right? Higher orders and so on. So what they are asking is, they are asking the coefficient of x minus pi square. So this is the term we have here, which is containing x minus pi square, right? This is that term. So the coefficient of x minus pi square is this divided by this. So the coefficient is f double dash at a is equal to pi divided by 2 factorial. So we have this f of x is equal to e to the power x plus sine x. So first derivative is e to the power x plus cos x, and second derivative is, B is the right answer, Kirti correctly said, is e to the power x minus sine x. So what is f double dash at pi? Put it here. So sine pi becomes 0 and this becomes e to the power of pi. So this value is e to the power of pi by 2 factorial. 2 factorial is 2. So this becomes 0.5 times of e to the power of pi. Right? Not a big question, small question. So all you have to do is remember the formulas, remember the expressions, what is the point about which the expansion is done, and all those things, right? But there are some tricks, I'll tell you that afterwards, like some of the questions if we can apply it, right? So this question is very easy, done. Everybody is getting the answer. B is the right answer. Let's move to the third part. We have already discussed one thing, which was if f of x is let's say integration from 0 to a f of t dt, let's say capital instead of writing small, let's write capital. Let's say capital F of x. Then f dash of x can be written as f of t, and let's say it is, instead of a, if it is x, f of x, right? This is a fundamental theorem understanding of the calculus. If you are making sure that f of t is continuous in this range from 0 to x, the integration from 0 to x, if it is f of x, then the derivative is going to be this function. So similarly, we have this f of x here, and we need to find the expansion a2 value. So before going to the a2, what is f of x going to be? We know this. This is going to be f of a. A is 0. This is x equal to a, which is 0, right? So I'm writing a equal to 0 first. We'll put it afterwards. Plus x, because h, which is x minus a, will directly become x. Correct? This is Maclaurin's, because x equal to 0 gives you a Maclaurin series. So if you check the formula for Maclaurin's, you will get it x into f dash of 0, or a, let's write a, plus x square by 2 factorial f double dash of a and higher terms. So we need this a2, which is coming with x square. So this is x square. So this f double dash of a by 2 is nothing but a2. a2 is the coefficient of x square, and what is it? F double dash a by 2 factorial. Very similar to the previous question, but the condition is this f of x is equal to from 0 to x e to the power of minus t square by 2 dt. So in that case, the first derivative for this case, f of x will be, f dash of x will become simply this function. This is f of t, right? Putting t is equal to x. You see this here? I told you, we have explained this. See, if this is f of t, you can directly putting t is equal to x gives you the first derivative, right? So in the similar manner, this first derivative is going to be nothing but e to the power of minus x square by 2, right? Because f of t is what? F of t is e to the power of minus t square by 2 in this case, right? We have already understood this. So the second derivative is going to be what? It is going to be e to the power of minus x square by 2 into differentiation of this, minus into 2x by 2. So this is minus x into e to the power of minus x square by 2. And what is a here? A is equal to 0. See, a is equal to 0. So f double dash of a, f double dash of a equal to 0. Put it here. So you'll get it 0. Right? So if this is 0, this term is going to be 0 by 2. So this is 0. So a2 becomes 0. So it is going to be 0. Getting my point? F of x is the integration of e to the power minus t square by 2. And then first derivative will become the function itself. You can replace t square with x, or you can replace t with x, I'll say. So that's what we have done here. We have replaced t with x to get the first derivative, and the second derivative is this one, and putting x equal to 0, because that is where the point of expansion is, we have been asked. So the the second derivative becomes 0, and ultimately a2, which is this function f double dash a by 2 factorial, becomes 0. This is a2. So the answer is 0. Let's see the next question. I am giving you two options. One option is you can do it conventionally, f of x, then the derivative, then the second derivative, and all those things. But my suggestion is, and that will always definitely help you, and that will be sometimes a direct question also, you should remember the standard expansions of some of the functions, like e to the power of x, sin x, cos x, tan x, like 2-3 terms, ln of 1 plus x, ln of 1 minus x, all these terms. There are few terms for which you should remember the expansion. So e to the power of x expansion is 1 plus x square by 2 factorial plus x cube by 3 factorial and so on, right? This is the expansion. And what we have been asked is e to the power of x plus x square. So by property, I can write it as e to the power x into e to the power x square, right? And when it is e to the power of x square, you substitute x square instead of x. So that means e to the power of x square becomes 1 plus x square plus x to the power 4 by 2 factorial plus x to the power of 6 by 3 factorial and higher terms, right? This is done. Now what we can do is we have to see that which includes the power of x less than or equal to 3. That means we have to expand it up to third order only, nothing higher than that. So x to the power 4 terms, x to the power 5 and all those terms should not be there. So what I am doing is, instead of doing it conventionally, which was finding the derivative, second derivative, which will take some time, what I am writing is e to the power x into e to the power x square becomes, I won't go beyond third order, right? Because that will be like higher than third order. So that's not what we are looking for. 1 plus x square by 2 factorial is 2 and 3 factorial is 6. Dot dot dot, but we are not writing those terms. And e to the power x square, I am writing only 1 plus x square. Why I am not writing x to the power 4? Because x to the power 4 multiplied with any of the terms from the first expansion will be higher than 3. So let's drop it. Of course there are higher terms, but we are dropping it because we need up to order 3 only. So let's expand this. For the first term, we'll have 1 plus x square. For second term, that is x, we'll have x plus x square. For third term, x square, we'll have like 1 by 2 times of x square plus x to the power 4. So x to the power 4 also has to be dropped. So let's not write this. And then 1 by 6 x to the cube should only be multiplied with this 1 plus dot dot dot. You can write it dot 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 here also, right? I am trying to avoid anything higher than 3. Now you can just arrange it. What is the arrangement? There is only one constant, so I am writing it 1. For x to the power of 1, there is only one term, which is x. For x square, there is one term 1 and another term is 1 by 2. So 1 plus 1 by 2. So this is 3 by 2 times of x square. And for x cube, there is only one term, which is this one. Anything else? Okay. One second. X square. Yes, one more term is there. X square is fine. This will be x cube. X plus x cube. This is not x square, this is x cube. And anything else? X cube by 6. Yes. So this is fine now. So this is from x cube and 1 by 6 we are getting 1 plus 1 by 6 x cube. So this is 7 by 6. So ultimately what you will get is we are getting is 1 plus x plus 3 by 2 x square plus 7 by 6 x cube and higher terms. This was x cube, not x square, right? Rest is fine. Why I did it like this? Because this will be easier, right? If you try doing this, instead of that, what you could have done? You could have found f of x, which is e to the power x plus x square, then f dash of x, then f double dash, and you will have to do it up to triple dash. Why? Because you need up to order 3. So up to order 3 means you will have to find all these terms, this one, and this one, and then you'll have to put it. So then also you'll get the same answer. The answer is going to be C option, right? This is what we are getting. So what 1 plus x plus x, please try to expand it. You will get this only. I'm telling you. Please expand it. Why and what understanding you need is you don't have to go above third order. Avoid anything above third order because they have asked you up to third order only, right? Aditi, right? Please do it. Then you'll get it. Don't although it is right, but if you are getting any confusion, you just do it instead of checking it here. Let's see this question. Quadratic approximation of this function. So if you want to find the quadratic approximation, then also what you will have to do? The Taylor expansion up to x square term. The cube terms will also be like reduced. In the previous question we did it up to x to the power of 3. Now you have to do only up to the power of x square. So this f of x can be written as about the point x equal to 0. So let's write directly f of 0 plus x f dash of 0 plus x square f double dash of 0 by 2 factorial, which is 2. So let's write it 2. Right? Now I'm writing what is f of x. F of x is x cube minus 3x square minus 5. What is f dash? F dash is 3x square minus 6x, and f double dash is 6x. Fine? 6x. 6x minus 6. Now what do you need? You need f of 0. So let's write it. F of 0 is minus 5. F dash at 0 is 0. F double dash of 0 is minus 6. Just put x equal to 0 there, you'll get it. Nothing big. You have found the first derivative, second derivative, third derivative. Putting x equal to 0, you have found the values. So once you have found the values, f of 0 is minus 5, so write minus 5. This term is 0, so let's drop it. This term is minus 6, so this is minus 6 by 2 into x square. So this function f of x now becomes minus 5 minus 3x square. That's it. So this is the quadratic approximation. Quadratic means what? Second order. F of 0 is minus 6. F of 0 is minus 6. The function is, Kirti, the function is x cube minus 3x square minus 5. Please look at, if you are not able to see it clearly, please focus. I am telling you the function is x cube minus 3x square minus 5. Put x equal to 0. The x terms will get 0. You will be left with only constant. For this you don't have to calculate anything. The constant part will be the answer. So f of 0 is minus 5, Kirti. Right? F double dash x is minus 6, because in that case you are finding the second derivative of x cube. So that will be 6x minus 6. So that means this is what you are getting, and this is option B. Option B. So you see some of the things which helped in our class today, and in case I am saying if you didn't get anything clearly, it could be because we are not very clear with it was direct answer. Lokesh, of course it was the direct answer. No, it is okay, Lokesh. It is directly answered. You can say it rightly, but it is fine if it is about x equal to 0. But what if they ask you about x equal to 2? Or they ask you about x equal to minus 5. In that case, you will have to do it. Fine. And anyways, you'll prefer to do it. So in this case, if it was x equal to 0, otherwise you will have to do it. X equal to 0. Yes, x equal to 0. See, some of the times we are doing it conventionally to tell you how to do it. What if tomorrow it is x equal to 2? Then how will you do it? So this is how you have to do it. The first expression for Taylor series was like f of x is equal to the expression we wrote it, x minus h into f dash of a, like that and all. So you have to take care of that, right? Of course, x square will be 0. X square won't be 0. Please do it. Find the derivatives and find the function derivatives at x equal to 0. Put it there. Okay, Ravi. Right. So not a problem. What my concern is here. So we are winding up here. My point is that a basic understanding of graph will help you to do any like too much of calculations in the questions coming from maxima, minima, increasing, decreasing, global maximum, minimum, all these sort of questions. A basic understanding of the graph, especially if it is coming from polynomial equations, it is very well. Polynomial equations have very good nature of like functions, we know that. Like there is a question, I think it is question from calculus only. It is like if there is an nth order of function, let's discuss this. So if there is nth order of function, nth order of polynomial equation, nth order of polynomial equation. So nth order of polynomial equation is like what? X to the power of n plus x to the power of n minus 1 with some coefficients, right? And so on equal to 0, let's say. So the point is here that nth order of polynomial can have maximum n roots. So n roots will include real roots also and complex roots also, and maybe sometimes repeated roots like x equal to 2 are the 2 roots twice, like x minus 2 whole square. You'll get 2 as repeated roots. So my point is there are overall n roots, out of which it can be repeated also, out of which it can be maybe complex roots also, complex conjugate also. So in that case, this is the maximum real distinct roots you are going to get for this function. The maximum real and different roots you are going to get for this polynomial equation. So that is the, what is this n roots? So what is this roots? Roots are the zero crossing. There is a question. There is a question for cubic equation in your somewhere. So if you say this x is equal to a is a root, why do you say this? Because at this point the function value is 0. And then you say a is a zero crossing, or you say it is a root, right? Any of it. So nth order polynomial can have maximum n roots, because of which we can have repeated roots or complex roots also. Now what about extrema? We find extrema at f dash of x is equal to 0, that is the stationary points. So if there is nth order of polynomial, the derivative will be n minus 1th order. The derivative is going to be n minus 1th order. So in that case, the maximum real different roots of this f dash of x is n minus 1. So that means for an nth order polynomial equation, there are possibility of having n minus 1 maxima. Maxima or minima, anything. So you can say extrema. So that is the maximum possible value. Maximum possible, like maximum number of possible extremas, not maximum minimum values of function. So maximum or numbers of extrema for nth order polynomial is going to be n minus 1. Because again there can be repeated or there can be complex roots also again. Right? And for people who were having some confusion with the graph, please check the graph of quadratic equations and so on. You'll see that it will be very clear. Right? So we'll wind up here, and for today's session you saw whatever we have learned, and you also saw that how we can do it graphically, avoiding calculations. That is important. That is where you save some time, right? That is where it makes you different from others. So that is all about today's session. It was really a good session. Thanks for like everyone having a good interaction and responding very well. And next class we'll be moving into integration, definite and improper integration, and then other application of integration and other topics. And then maybe after that we'll be moving into vector calculus, right? So okay then, share these videos with your friends and put a thumbs up on the video. And like for those people who have not installed and registered, you can install and register the application also. Okay then, happy Sunday. Bye bye everybody.